Hello viewers, in this lecture we're going to discuss about the extent of a reaction that it's dependent on the value of the Kc. Now you will be thinking that Kc is a condition at which the reaction is at equilibrium and that should be always equal to 1. So why I'm saying that extent depends on the Kc. So basically their value should be 1 as an end result. We know that the formula of the Kc is concentration of product upon concentration of the reactant, right? But it's not permanent that the value of the reactant and the product should be 1. But there is a condition that value of the P should be equal to the value of the R. Just suppose that I do have a extent, just suppose for instance I do have 2 moles of both of the reactant and the product. That means that the concentration of the product is 2 as well as the concentration of the reactant is 2. So what will happen? 1, then 1, answer is 1. This is a equilibrium state because our final answer is 1. That's not compulsory that the answer or the value of the P and R should be 1. So that's one thing. And we're going to discuss about the extent of reaction on the basis of these values. Now let me give you an example of a reaction and let's see how we can identify these type of reactions. Now there are three conditions in the extent of a reaction. Let me create a white space so that I can explain. Okay, so for a reaction there are 3 possible conditions. Whether a reaction is larger, that means the extent is larger. Whether a reaction is smaller, that probably means the reaction that is being used is smaller, and whether the reaction can be moderate. Now these are 3 conditions on which the extent of the reaction relies. When we are talking about the larger, so basically that probably means the value of the Kc that can be anything that should be greater than 1. Now what does that mean? That means it can be 1.5, it can be 2, it can be 2.5, 3, 3.5, larger than 2. So we took it as the larger extent. When we are talking about the smaller extent, that probably means that should be less than 1. And when we are talking about the moderate state, that probably means the value should be equal to 1. There is this is a rare condition that not probably rely, but we do study it because some of the conditions also include these type of extensions. Now one thing to be noted is that when we say that the value of the K is larger or smaller or moderate, so here we are indicating the reaction direction too. We are indicating the stability too. Now let me explain it by an example. Now just suppose that this is a hypothetical representation of a chemical reaction where A is a reactant and B is the product. At the instant when the time is 0, like reaction haven't started yet, so we do know that the reactant side is more as compared to the product side. Product side is always 0 at the start of the reaction. As the reaction increases, the reactant goes downwards and the product goes upwards. What does that mean? That probably means the reactant start decreasing and the product start increasing. And there is a condition where the reactant becomes 0 and the product becomes more than the starting product. There can be a excess product too, but that depends on the condition, that depends on the inception. Now here we can see that there is a condition in which both of the reactants and the products are equal, 1.5. This is what? This is a Kc, the equilibrium constant, where the concentration of both the reactant and the product are same. Now just suppose that if we're gonna we have to confirm that it is a equilibrium or not. So we're gonna just put it as in the formula, that is 1.5 upon 1.5, and we're gonna cancel it out by 1 and 1, and that is equal to 1. Yep, this is a Kc equilibrium constant. Now the condition at which we identify whether it is a larger product, whether it is a smaller product. So first we have to look at what 1.5 is. Is it larger than 1? It is smaller than 1? Is it they're equal to 1? So basically it is larger than 1. That probably indicates that this is a larger extent. Now what it shows? It shows that the reactant is weak and the products are strong. Now what I am trying to say is that this means that the reactant side is unstable and the product side is stable. Now this shows us basically that the reaction here is fast reaction. That means that these kind of reactions included all the assumptions that can be made for the product. Now here thing to be noted is that whether if the extent is larger, that indicates that the reaction is almost completed or is completed. This is a important point to be noted, because here if we talk about the complete reaction, so it probably means that the Kc is at the larger extent. There isn't a larger value of the Kc. Now if we talk about another condition which is smaller than 1, just suppose that for instance, let me remove it. Okay. For instance, this is not 1.5, this is 0.5. For instance. Now first we have to have a look that is it greater than 1, is it less than 1. So basically it is less than 1. What that indicates? That indicates the side of the reaction where the reactants are stable and the product is unstable. Because here the reaction is started. This indicates that it is a slow reaction and reaction is just started. So this is a condition that can be applied and that can be assumed. So I hope that you get these reactions and their concentrations, products and all the equilibrium constant. And thank you for watching this video.